Hi students, a very good morning. In this section we enter into the third unit, classification of elements and periodicity in properties. Classification of elements and periodicity in properties. Simply we can say that classification of elements. In this chapter we have to discuss the historical development of classification of elements and different type of periodic tables. Okay, many scientists classify the elements according to atomic masses, atomic number, and the historical development leads to the modern periodic table. Why do we need to classify the elements? What is the purpose of classification of elements? As earlier in the beginning of 19th century, in 1800 there are only 31 elements. Okay, in 1800, in 1800 there are only 31 elements. Okay, there are only 31 elements. But in 1865 the number of elements are 63. 63 elements were found. Okay, 63 elements. Almost double, more than the double. Okay, more than the double number of elements discovered or identified in the 1865. And the study of this much elements. Okay, one or two elements, the properties and their compounds are easy to study. The study of this much elements is difficult. Now, in 2016 there are 118 elements. Okay, 118 elements. In our periodic table, there are 118 elements. Okay, 118 elements are there. So, the study of this much element make a difficulty. Because one compound one element form many compounds. For example, carbon forms many compounds, oxygen form many compounds, hydrogen form different type of compounds. So to study the properties of compounds and elements is a difficult task. In order to overcome this difficulty, the similar property elements are classified in a group and dissimilar elements are in the other group. Okay, so similar elements group identify and study their properties. For example, alkali metals. Alkali metals have a general trend. Okay, so this is lead to the classification of elements. As earlier, in 1829, okay, in 1829, many scientists made a classification, but one of the successful classification is made by Johann Dobereiner. Okay, Johann Dobereiner. And you know the name of the classification or the law of Priors. Law of Priors. Okay, he classified the elements according to the increasing order of atomic weights, and the atomic weight of the second element or element in the middle is the midway of the atomic mass of the other two elements. Okay, it's very simple. The atomic mass of the middle element is the arithmetic mean. Okay, or the midway, the arithmetic mean of atomic masses of the first and the third elements. Okay, as you know that lithium, then sodium and potassium. Atomic mass of lithium is 7. Atomic mass of potassium is 39 and sodium is 23. How this 23 is obtained? The arithmetic mean of atomic masses of the other two. Okay, the arithmetic mean or the average of the atomic masses of the first and the third element. Another triad is chlorine, bromine and iodine. Okay, chlorine, bromine and iodine. Chlorine 35.5. Then bromine 80 and iodine is 127. Iodine is 127. And arithmetic mean 35.5 plus 127 divided by 2 is equal to 81.25. This is similar to 80. Okay, it is very close to the value 80. So Davanier classify the elements as triads. Tri means 3. Okay, so 3 elements in a group. It is called a triads. And the atomic mass of the second element or the middle element. Okay, atomic mass of the second element or the middle element is arithmetic mean of the other 2 elements or midway. Midway means paudi. Okay, paadi vadi. Okay, paadi vadi enartham, paudi enartham. So the midway of the atomic masses of first and the third element, that is triads, law of triads, a very simple concept. And many triads, you know that. Another triad is calcium, strontium, barium. Okay, you practice it. You practice the triad. Calcium is 40, strontium is 79 and barium is 137. Okay, sorry. So calcium 40, strontium 79, barium is 137. You practice it. Okay. Then we move to the another one. In 1862. Okay, this is the history. Just 31 elements in the 1800 or 1800. Then 1865, 63 elements, more than the double of the 31 element. In 2016, the 118 elements were named. Okay, so now we have 118 elements. Then the first successful classification is done by Johann Dobereiner and the law is known as law of triads. These are the examples. Then in 1962, okay, another development is in 1862. Not 1962, 1862. Okay, a geologist, a French geologist, A.E.B.D. Charpentier. Okay, A.E.B.D. Charpentier. He was a geologist. He make a telluric helix. Okay, what is telluric helix? In a cylinder, he draw a helix in the 45-degree angle. Okay. He made a helix in the 45-degree angle. And the elements which having similar property which comes in the similar position. Okay, the elements having the similar property comes in the similar position of line in the telluric helix. Okay, that elements in increasing atomic weight arrange ചെയ്തു. ചിലപ്പോൾ നിങ്ങൾ അത് കേൾക്കാത്ത ഒരു കോൺസെപ്റ്റ് ആയിരിക്കാം. അങ്ങനെ എലമെന്റ്സിനെ ഇൻക്രീസിംഗ് ഓർഡറിൽ അറേഞ്ച് ചെയ്തപ്പോൾ അതെങ്ങനെയാണ് അറേഞ്ച് ചെയ്തത്? ഒരു ഹെലിക്സ് പാറ്റേണിലാണ്. ഒരു സിലിണ്ടറിക്കൽ ഇത് എടുത്തിട്ട് പേപ്പർ എടുത്തിട്ട് അതിനകത്ത് എന്ത് ചെയ്യുക, ഇങ്ങനെ ഹെലിക്സ് ഡ്രോ ചെയ്യുക. എന്നിട്ട് എലമെന്റ്സിനെ അറ്റോമിക് മാസിന്റെ അറ്റോമിക് വെയിറ്റിന്റെ ഇൻക്രീസിംഗ് ഓർഡറിൽ അറേഞ്ച് ചെയ്യുമ്പോൾ സിമിലർ പ്രോപ്പർട്ടിയുള്ള എലമെന്റ്സ് എല്ലാം സിമിലർ പൊസിഷനിൽ വരുന്നു. അതാണ് AEBD Charpentier പ്രൊപ്പോസ് ചെയ്ത ടെലൂറിക് ഹെലിക്സ്. ഓക്കെ, ഒന്ന് ഓർമ്മയിൽ വെക്കുക. Then നെക്സ്റ്റ്, ഇതിനകത്തും കുറെ ഡ്രോബാക്സ് ഉണ്ടായിരുന്നു. സോ നെക്സ്റ്റ് ഈസ് John Alexander Newlands proposed a law of octaves. Okay, who proposed the law of octaves in 1865. In 1865, Newlands, full name is John Alexander Newlands. Okay, Newlands propose a law of octaves. Law of octaves. In this classification, elements are arranged in the increasing order of atomic weight. Okay, elements are arranged in the increasing order of atomic weight. And the eighth element having similar property of the first element. So very important. Elements are arranged in the increasing order of atomic weight. Eighth element has a similar property to that of the first element. And he arranged the elements. Lithium, atomic mass 7. Okay, I write here because it is, the atomic mass is left superscript, written in the left superscript. Beryllium 9, boron 11, carbon 12, nitrogen 14, oxygen 16, fluorine 19. Okay, fluorine 19. And next is sodium 23. Sodium is 23. Then magnesium 24. Aluminium 27. Silicon 28. Phosphorus 31. Sulfur 32. Chlorine 35.5. Then potassium 39. Calcium 40. Okay. So Newlands arranged the elements in the increasing order of their atomic weight, and the eighth element has similar property with that of the first element. You count it. 1, 2, 3, 4, 5, 6, 7, 8. So lithium and the sodium also with a similar property. And starting from here, 1, 2, 3, 4, 5, 6, 7, 8. Beryllium and magnesium similar property. You can start from here. 1, 2, 3, 4, 5, 6, 7, 8. Similar property. And this is similar to the octaves in the musical notes. In a classical song, we know that Sarigama Padanisa. Sa repeats. Okay. The eighth sound repeats in the classical notes. So similarly, in Newland octaves, the eighth element having similar property. Okay, all these things you know that I think. Then the law is flawed. The drawback is then only the properties are not similar. Scandium, titanium. Okay, so up to this one is correct. And the drawback of Newland octave is higher elements couldn't flow, cannot flow. Okay, higher elements cannot flow this law of octaves. That's a drawback of Newland's octaves. And in 1869, another year, 1869. Okay, 1869. Two scientists. One is Lothar Meyer. And Dmitry Ivanich Mendeleev. Okay, shortly written as Dmitry Mendeleev. It's a Russian chemist. Okay, he was a Russian chemist. He classified. Okay, Lothar Meyer and Dmitry Mendeleev independently arranged the elements according to their weights, atomic weights. And Lothar Meyer plots the physical properties such as atomic volume, density, melting point, etc. versus atomic weight. Okay, so Lothar Meyer plot a graph between physical property versus atomic mass, and he concluded that the similar properties of some similar elements which comes in the similar position. Okay, so he plot the atomic volume. Then similar property elements comes in the similar position. You don't study this, I just draw it. He plots atomic volume against the atomic masses. Atomic mass increases, atomic volume increases, and the elements having similar property occupy the same position or similar position in the plot. Okay, suppose lithium is present here, sodium, potassium, rubidium. Okay, atomic volumes are in this similar position, and this law is not widely accepted. At the same year, 1969, Dmitry Mendeleev classified the elements according to the atomic weight, and he stated one law is called the periodic law. Okay, periodic law. The properties of elements are the periodicity in the atomic weight. That means atomic number increases. The elements with a similar property repeats after an interval. Okay, according to Dmitry Mendeleev periodic law, the elements having physical and chemical property. The properties of elements are the periodic functions of their atomic weight. If elements are arranged in the increasing order of atomic weight, those elements with a similar property repeats after an interval. Okay, repeats after an interval. He arranged the elements in a vertical column as well as horizontal rows. Okay, he arranged the elements in the vertical columns as well as in the horizontal rows. Vertical columns are called groups and horizontal rows are called periods. Okay, you know the Mendeleev periodic table. I just erased the new lines octaves. So these are the historical development of periodic tables. Mendeleev periodic table. In Mendeleev periodic table, the elements are arranged in a vertical columns. Okay, vertical columns. And these columns are referred as groups. Zero group, first group, second group, third group, fourth group, fifth group, sixth group, seventh group, and eighth group. Actually, in his periodic table, there was 8 groups. Okay, there actually in the earlier suggestion, he gave only the 8 groups. Later, the discovery of noble gases. Noble gases do not form any compounds. That's why he added one more group, zero group. Okay, in zero group, the noble gases are there or inert gases are there. Okay, helium, argon, krypton, xenon. Okay, helium, neon, argon, krypton, xenon. At the time of the discovery of Mendeleev periodic table, only few noble gases were discovered. Okay, only few noble gases were discovered. Remember that. And he Mendeleev arranged the elements in the group wise and rows wise. Okay, vertical columns and rows. There are 7 rows. Okay, there are 7 rows in his periodic table, and the rows, periods are numbered as 1, 2, 3, 4, 5, 6, and 7. Okay, so how many groups are in the Mendeleev periodic table? There are eight groups, and later on added 0 group, and there are 7 periods. The periods are numbered as 1, 2, 3, etc. And the groups are numbered as 1, 2, 3, 0, 1, 2, 3, etc. in Roman numerals. Okay. And the merits of the Mendeleev periodic table is he classified the elements according to the atomic weight. That is one of his merits. He classified the elements according to the atomic weight. And the second merit is he predicted some elements. Okay, the elements predicted by Mendeleev, he predicted the elements Ega aluminum and Ega silicon. And later the elements was found. Okay, and later the elements was found. The properties similar, exactly similar to the properties described by Mendeleev. Okay, Ega aluminum, which is Ega aluminum. Okay, it is gallium. Okay, Ega aluminum is gallium. What is Ega silicon? Okay, Ega silicon in the carbon family, carbon, silicon, germanium. Germanium is Ega silicon. Okay, so you know these things. Ega aluminum is gallium and Ega silicon is germanium. And the properties is almost closely related to the property explained by or described by Mendeleev. So his merit, one of the important merit is he predicted some elements and their properties. Are you clear? Yes. Then another important merit is he calculated the atomic weight accurately. Okay, he calculated the atomic weight accurately. Some elements the atomic weight is not calculated accurately. Okay, for example, in the case of beryllium, the atomic mass is calculated 13.5. Okay, 13.5 by equivalent weight. Okay, by the calculation of equivalent weight. But actually, the atomic weight of beryllium is 9. It is calculated by Mendeleev. Okay, then so these are the important merits. Okay, merits of Dmitry Mendeleev. Also, he has some drawbacks. What are the drawbacks in Mendeleev periodic table? In Mendeleev periodic table, the position of hydrogen is a question mark. Okay, he couldn't place the hydrogen in a proper place. That's one of the important drawback. And another important drawback is anomaly. Okay, anomalous pattern in the atomic number. In some areas, the elements succeeding the elements with a higher atomic mass. Actually, he arranged the elements in the increasing atomic mass. But in cases, some groups, some elements preceding with a higher atomic mass, or some elements succeeding with a lower atomic mass. In the case of cobalt and nickel, cobalt atomic weight is 59. Okay, the atomic mass or atomic weight of the cobalt is 59, but that of nickel is 58.5. Okay, or 58.7. So nickel comes after cobalt. Actually, it comes in the increasing order, but some cases the elements order is different that of he proposed the law. And another case, tellurium. Tellurium with atomic mass 128 precedes iodine with atomic mass 127. ഞാൻ പറഞ്ഞത് മനസ്സിലായോ? ചില സിറ്റുവേഷനിൽ ഹയർ അറ്റോമിക് മാസ് പ്രിസീഡ് ചെയ്യുന്നു, മുൻപിൽ വരുന്നു. ലോവർ അറ്റോമിക് മാസ് സക്സീഡ് ചെയ്യുന്നു, പിന്നീട് വരുന്നു. ആക്ച്വലി എന്താണ് വരേണ്ടത്? അറ്റോമിക് മാസിന്റെ ഇൻക്രീസിംഗ് ഓർഡറിലാണ് അറേഞ്ച് ചെയ്യേണ്ടത്. അപ്പൊ ലോവർ കഴിഞ്ഞിട്ട് ഹയർ ആണ് വരേണ്ടത്. ബട്ട് സം കേസസ് ലോവർ അറ്റോമിക് മാസ് സക്സീഡ്സ്, ഹയർ മാസ് കഴിഞ്ഞിട്ടാണ് ലോവർ അറ്റോമിക് മാസ് ഉള്ള എലമെന്റ്സ് വരുന്നത്. അതും ഒരു ഡ്രോബാക്ക് ആണ്. ചില സിറ്റുവേഷനിൽ അങ്ങനെ അദ്ദേഹം എഴുതേണ്ടി വരും. Then some other drawback is Dissimilar properties ഉള്ള എലമെന്റ്സിനെ എല്ലാം സെയിം ഗ്രൂപ്പിൽ കൊണ്ടുപോകും. For example, copper, silver, gold. Okay, properties are different, properties are dissimilar, but he placed these elements in the same group. And similar property ഉള്ള എലമെന്റ്സിനെ ഡിഫറെന്റ് ഗ്രൂപ്പിൽ വിട്ടിട്ടുണ്ട്. കോപ്പറും മെർക്കുറി ഓൾമോസ്റ്റ് സിമിലർ പ്രോപ്പർട്ടീസ് ആണ്. കെമിക്കൽ പ്രോപ്പർട്ടീസ്, കോമ്പൗണ്ട് ഫോർമേഷൻ, ഇതെല്ലാം സിമിലർ ആണ്. അപ്പൊ സിമിലർ പ്രോപ്പർട്ടി ഉള്ള എലമെന്റ്സിന് ഡിഫറെന്റ് ഗ്രൂപ്പ്സിലും ഡിസിമിലർ പ്രോപ്പർട്ടി ഉള്ള എലമെന്റ്സിന് സെയിം ഗ്രൂപ്പിലും എന്ത് ചെയ്തു, അദ്ദേഹം ആഡ് ചെയ്തു. ദാറ്റ്സ് വൺ ഓഫ് ദി another important drawbacks. And the main drawback is he couldn't place the isotopes in the periodic table. Okay, you know that what are isotopes? Isotopes having same atomic number and different mass number. Okay, so isotopes couldn't included. He couldn't place a proper place or proper position for the isotopes. So that's why he is failed to explain the properties of isotopes. So these are the developments in the periodic table. And later in 1913, remember that when Mendeleev proposed the periodic table in 1869, the electrons, protons, neutrons were not discovered. The subatomic particles was not discovered. Okay, then after the discovery of the subatomic particles in 1913, Henry Moseley, an English scientist, Moseley and co-workers developed a periodic table which is known as modern periodic table. Okay, so the discussion of modern periodic table we will do in the next section. Thank you.